Hi, welcome to this short video about the state handler. I prepared an example, and the example is pretty simple. I have a main CPP where I initialize the I/O that we need later, and in the while loop I have our known structure. We have an object, in this case of type C test, it's called test object, and we will run the state machine that we have implemented in that system. Okay, let's first start with the header file. The header file has our states from the object test defined. I have an unset value which we don't use, and we have three different state values: state 1, state 2 and state 3. And to keep track of the states, of course, we need a variable state of type test states, test states that we had here. And I need a state handler of type C state handler that keeps track of some data for us that are very useful and make the implementation pretty simple. Do STM we already had, and this C test is a constructor that is being called at the moment that we are creating, or the software is creating, our test object, and I'll come back to that later. Then we go to the test.cpp. Here we see our constructor, as I said here, a default constructor. It's being defined as we are used to. We have our class name, then a double semicolon, and then we have the function name. And in this case, the function name of the constructor is exactly the same as the name of the class itself. Well, what does this constructor do? At the moment an object is instantiated or created, we set our state to state 1, so that we never end up in unset here, but always in state 1. And we need our state handler .setNextState, where we tell our state handler that the state we are going to enter is equal to state 1 in this case, so that we end up here. And as you can see in do.stm itself, every state has a state handler .setNextState in it. So we inform our state handler if something happened with the current state and we want to go to something else. Okay, what do we do? As I said, we start in state 1, and state 1 goes directly to state 2, calls to setNextState to inform the state handler that we are going to another state. And also we set a counter value to 0 that we use later. When we are in state 2, we are waiting for a time to elapse, 3000 milliseconds or 3 seconds. So as you can see, the first 3 seconds nothing happened, and when the 3 seconds have passed or elapsed, we increment our counter, and as long as our counter is less than 4, then we go back to state 2. So we stay here, which is of course pretty useless because we are already in state 2, but just for clarity. And when counter is 4 or more, we get in the else path, and then we go to state 3. And every time, and at that time, after the 3 seconds, of course, we have to tell the state handler that we want to go to a next state, or better, that we are making a state transition. So if we are in state 2, after 3 seconds, and the counter is less than 4, we still are in state 2, and we tell the state handler, hey, we are going from state 2 to state 2. So we're making a transition, and the transition will establish the fact that our elapsed time counter is being reset. I'll show you that later. Okay, when counter has become 4, we go to state 3, and in state 3 you see something like an on entry that you had to make during your exam assignments, sorry. The state handler implements it for you, and only the first time that you get in state 3 on entry is true, and we will reset the counter. And in all other cases we'll just wait for a switch to be pressed, and when we press the switch we go to state 1 again, and then we tell the state handler, hey, we are entering a new state, please handle this. And the handling itself is done at the last line here, state handler dot handle state will perform some things for you. Well, and what it does, I will explain to you when we are running the software. That's yeah, about it. Here is the state handler. It has 3 functions. A constructor also, as you can see, statehandler.cStatehandler. That's the moment we are creating our state handler from our test object, which happens, of course, when an object is created, we are creating a state handler. It will set its own variables next state to the largest value possible, its current state variable, and its start time to the current time in milliseconds that your processor is running. Here we have the set next state, and the only thing it does is that the state we pass in new state is being put in next state, so that next state. And the handle state checks if next state was unequal to this 0xFFFF, and when it is, it will say, okay, the next state here that we set, calling set next state, will be our new current state. Start time will be refreshed to the time of the millisecond counter at that moment. Next state is being reset again to the big value here, and we know that this will only happen now the moment we are entering a new state. So on entry flag that we check here will be set to true, and the next time when we do a handle state, this will be false because next state is again this value. On entry flag will be reset. And then we have an elapsed time to do some timing, and this is the, where is it, here, elapsed time of the state handler. And the only thing that it does, it returns the difference between the current millisecond value and the moment that we entered it here, and we stored it on start time. So this is a millisecond counter, more or less. Well, that's it. Let's just build it. Go to the debugger. And we end up in main, but it's not something I want to start here somewhere. Press run. So we are in state 1, and state 1, this is 0, this is 1, so we are in state 1 as this constructor already set for us. And when we look at our test object, we see also here that we are in state 1, and we see that the state handler has an on entry flag false. Start time is of course 0 because the millisecond counter was 0, and our next state was 1, of course, because it is that we are in state 1 here, and our current state has not been set yet because that is being done where it is. Current state is being set when we call handle state, and we are here and have not entered handle state there. So we are in state 1, so when I step through it, we are in state 1, we will set state 2. I will now enter the set next state, and the set next state will put the internal flag of next state of the state handler, so this one, to our new value 2 in this case. When I step through it, you see that it changed. Counter reset, then we go to the last line where we handle the state, and I'll also enter that one. Of course, now our next state is still changed, sorry, because we are going to a new state, so we will have to run this piece. It will do it. It will set the current state to the state that we had the next state. Start time will be stored, which will still be 0 because there's no millisecond passed yet. And the next state will be reset to our FFFF, as you see. And the on entry flag is set to 1 whenever we need it. Go back to that one. We are now in state 2, so we end up here. Oh, we end up here. I'll remove that one. And now nothing will happen until our time elapsed is 3 milliseconds. I'll run 1, 2, 3. Well, there it is. Now the counter will be incremented. It already saw something. And we will go back from state 2 to state 2. I enter it using F11. It will set it, of course, nothing new. And now the handle state sees, okay, it's 2, it's different again. So it will do the same as we just saw. Reset the start time. And of course the current state will not change because it was already 2. For the rest the process is equal. Okay. Now there's a moment that we enter 3 when the counter has incremented. So I'll run to that. Eventually we end up in state 3. We see that on entry is 1, so we will go here, come, and reset our counter, as you can see here. And our handle state, well, see that we did not set a new state, so it will reset our on entry in this case. When we are back in state 3, in this case, on entry is false, so we will skip the on entry part and just wait for our switch. Switch 1. I'll run and press our switch 1 on the board. And you see that we will return to state 1, and I will put a breakpoint over there, and we're back in state 1. Well, this is basically the principle of our state handler. That is a pattern that you will learn to use, and a little bit of it you already had. But the main things are we need a set next state to inform the state handler, and always at the end of your switch of your state handling you will have to call state handler handle next state. Well, that's it. Thank you for watching, and until next time.